So, good day, everyone, and we will be talking about cloud and healthcare data management. Presented to you by Group 5.
Cloud computing. What is cloud computing? Cloud computing is the delivery of computing services such as servers, storage, databases, networking, software, analytics, and intelligence over the internet or the cloud to offer faster innovation, flexible resources, and economies of scale. Cloud computing has benefits for healthcare. The economic benefits of cloud computing are it provides cost flexibility and the potential for reduced cost. IT resources are required on demand as needed and paid for as an operating expense. The cost for staff needed to maintain and deploy IT resources are included in the cost for cloud computing. For the operational benefits of cloud computing, cloud facilitates technologies that are used in healthcare like electronic medical records, mobile apps, patient portals, devices with IoT, big data analytics. It provides hassle-free scalability and flexibility, which in turn improves the ultimate decision-making process. Cloud services can offer sophisticated security controls, including data encryption and fine-grained access control and access logging. Cloud services can offer better security and privacy for health data and health systems. For the functionality benefits, healthcare functionality can be enhanced by cloud-based healthcare IT systems that offer the potential for broad interoperability and integration. Speed is a significant criterion before making decisions about selecting any technology. Cloud-based tools can update and upgrade their features at a commendable pace with minimal intervention, and you can get real-time updates as well as all the relevant information. Next, cloud services can enable remote access to applications and data via the internet using wired and wireless system to enable access at any time from anywhere that internet connectivity can be established. Sharing facilitates collaboration. With cloud computing, the process of data sharing has become a lot easier and simpler. Apart from sharing, they can also remotely access medical reports and records anytime, anywhere. Cloud has also facilitated remote conferencing, quick updates on healthcare developments, and patients' conditions, which altogether make it a perfect companion for healthcare professionals. Cloud services also offer access to a much larger ecosystem of a healthcare provider, payer, life sciences, and IT solution partners, all of which increase the potential for a wide range of services to healthcare provider organizations. The greatest functional benefit of healthcare cloud services is the wide range of new capabilities that they are able to offer. These services offer the opportunity to extend the capabilities available to the health organization staff in order to implement better ways of working and to offer new services to the patient.
High value cloud computing services for healthcare. First is the population health management. Cloud and big data services can be used to track diseases, map them geospatially, and inform the population where the risk exists. Healthcare organizations can implement the services and infrastructure required to support these services for a fraction of the cost by utilizing cloud computing. Examples are Centers for Disease Control and Prevention, or CDC, IBM Exploris, eClinicalWorks, McKesson, Kerner, and IBM Vital Population Health Management. Another example is care management support. These solutions provide cost-effective implementations, offloading tasks from hospital IT departments, allowing them to focus on supporting other operational and clinical support systems. Examples are IBM Watson Care Manager, man- which manages care for a patient across all steps in the care process, Next is diabetes care, eClinical Works, EHR, and McKesson. For diagnostic support, these organizations are developing new SAS products and services to both concentrate and the expertise required and lower the cost of operations for healthcare providers. Examples are iNuke IR retinal scanning screening combines automated images analysis tools with a user-friendly telemedicine or cloud-based interface to address the need for faster screening of more diabetic patients. Next is the IBM Merge iConnect retinal screening enables capture, storage, and sharing of images and notes between providers performing diagnoses and those creating care plans. For the image handling services, these services allow healthcare organizations to scale storage devices at a fraction of the cost that would be required to implement them internally by minimizing the overall TCO, the reduced capital expense, reduced staffing costs, and geographic distribution. Another example is IBM Merge iConnect Access enables medical image viewing across a wide range of devices. IBM Merge iConnect Cloud Archive secures cloud-based storage and access of medical images. Third is McKesson Picture Archiving and Distribution, Radiology Information, and Cardiovascular Imaging. Last is the RxI Cloud Infrastructure for network diagnosing imaging. For medical practitioner assistance, cloud services allow medical practitioners to search vast amounts of data to produce more recent treatment plans. Patients can utilize these services to explore their medical issues and collaborate with their treatment provider. Examples are Flatiron Oncology Cloud Suite of tools for oncology. Second, Varian Full-Scale Oncology IT Solution Oncology and Treatment Planning System. Third example is the IBM Watson for Oncology Cognitive Assistance for Oncology Professionals. For patient connectivity, the services which address patient connectivity enable patients to connect to the health services of healthcare providers. Examples are eClinical Works, Cerner, and IBM Truven Micromedex Patient Connect Suite. For data distribution services, these enable the exchange of key health-related data between organizations, such as electronic health records, patient images, etc. Examples are IBM Merge eMix, exchange of patient images and other health information. Second is the medical interoperability gateway provides a system for exchanging medical data in the UK. Third is the CalIndex, California Integrated Data Exchange, is a health information exchange system for the state of California. So for laboratory services, these support clinical laboratories in their work. Examples are Cerner Laboratory. Second is Media Lab cloud-based software for the lab and IBM Merge LIS Clinical Laboratory Information System. Okay now, okay. For clinical research, the explosion of data from next generation sequencing, as well as the growing copyright cloud standards, Customer Council page 12, importance of biologics in the research process is making cloud computing an increasingly important aspect of R&D. Pharma firms no longer are required to implement the capacity to handle large data sets in their computing facilities, lowering the barrier to entry and increasing the velocity of change. And here are examples for the clinical research. First is the Medidata Clinical Cloud, and second is the IBM Merge eClinical OS management system for conducting medical research. Intelligent business process management and case management on low or no code services. Gartner defines business process as a service as the delivery of business process outsourcing or BPO services that are sourced from the cloud and constructed for multi-tenancy. Services are often automated, and where human process actors are required, there is no overtly dedicated labor pool per client. The pricing models are consumption-based or subscription-based commercial terms. Examples of these are Gartner Research or the IBPMS, IBM Merge Financials Back Office Automation for Billing Accounting, IBM Merge Document Management Paperless Office Solution for Healthcare Organization.
Is the three systems and measuring, managing, and monetizing data. Health Catalyst has been helping healthcare organizations measure, manage, and monetize data for more than a decade by using a three-system approach for achieving meaningful, sustainable outcomes improvement. In this approach, best practice, analytics, and adoption are brought together to enable system-wide sustained outcomes improvement. The framework asks, what should we do? How are we doing? And how do we transform? The three M's of infonomics. It involves similar three-component system for health systems to become information savvy. Linus book asks organizations to think about managing data. What data do we have? Measuring data. What is our data worth? And monetizing data. How do we use data to transform? With an investment in a robust data analytics program to measure data, powerful infrastructure in place for healthcare data management, and right tools and resources in place to monetize data. Healthcare organizations can begin to use their valuable data asset to its full potential in order to drive better health and financial outcomes for patients and providers. Measuring data. Data is everywhere in a healthcare organization. Data is constantly being generated throughout the system through the normal activities of conducting business and providing services. The billing system, EMR, prescription writing software, and a chatbot. Most healthcare systems recognize that much of this data has value, but many have failed to treat it as they would a tangible asset.
For managing data, once health organizations have acknowledged the value of their data or measuring data, the next step is to determine where it's coming from and how it is stored. Effective healthcare data management means understanding where the data is and the ability to get the data into some form where it can be appropriately managed. In monetizing data in healthcare, the monetization of data is not just about money. It means improving the quality of care, improving patient experiences, lowering the cost of care that's been being delivered, discovering new revenue streams, improving the lives of care providers, or optimizing services.
Influence of digitalization, IT it is the enabler that allows consumers to take greater control over their healthcare choices. Around the globe, healthcare reform has mandated that it's time for healthcare IT to be modernized and that good computing is at the center of this transformation. Focus on preventive healthcare. Prophylactic interest has led to greater engagement with consumers to provide better aftercare and community-based healthcare. Consequently, mobile application, the Internet of Things, and wearable technologies, most of which supported by cloud applications are becoming more commonplace. In addition, healthcare delivery is becoming more decentralized and thereby providing a wider choice of institutions where the patient can receive care. For example, hospitals, retail clinics, or at home using telemedicine and accessing hospital portals.
Need for medical practice and healthcare delivery transformation. So professionals and organizational healthcare providers are predominantly physicians in private practice and general hospitals respectively. Conduct the business of healthcare according to standards and practices that may vary significantly. Standards of care differ by specialty and pathology. Clinical care and treatment practices vary with provider experience and local and best practices for optimal case outcomes without risk or increased patient morbidity or mortality remain elusive.
Balik anay sa laboratory services.